part 2 wants me to solve using Cramer's rule, or question 11 wants me to solve using Cramer's rule. And on the test, this question will have, it'll look like this. The answer blank for this question will have a D sub x, a D sub y, an x, and a y. I think you get a point or two apiece for each one of these. D is the determinant that you get by just taking the coefficients of the x's and the y's. And we calculate a determinant by cross-multiplying and subtracting. So I'm going to cross-multiply that way, cross-multiply that way. I'm going to do 4 times 5 and get 20, and 2 times negative 2 and get negative 4. And for determinants, you subtract. So it's going to be 20 minus negative 4. That's going to turn into 20 plus 4. So the D number is going to be 24. On the test, if you get the right answer, but don't show me what D sub x, and D sub y is, you're going to lose monster points. D sub x is what we get by taking the D matrix and we change the x column to the numbers in the equal sign. So that 4, 2 I'm going to change to 5, 2. And I'm going to leave the negative 2, 5. So I'm just changing the x column of the D matrix to the equals column. And now I'm going to find my D sub x by cross-multiplying both ways. I'm going to go 5 times 5, which is 25. 2 times negative 2 is negative 4, and subtract those. So 25 minus a negative 4 is the same thing as 25 plus 4, which is 29. Lastly, I need to get the D sub y. D sub y, you need the D matrix, which was 4, 2, negative 2, and 5. The D sub y, you change the y column of the D matrix to the equals column. So I'm going to write 4 and 2, and then I'm going to write 5 and 2. And I'm going to cross multiply down and get 4 times 2, which is 8. Cross multiply up and get 2 times 5, which is 10. And subtract those. 8 minus 10 is going to be negative 2. Done with the hard part, now forming fractions. X is D sub x divided by D. So in this particular problem, x is D sub x over D. D sub x is 29. D is 24. So the x is the fraction 29 over 24. Y is the D sub y number divided by D. D sub y is negative 2. D is 24. That fraction is going to reduce by 2 to negative 1/12. So for the answer on the test, in this order, you're going to have to put all of those. D is 24, D sub x is 29, D sub y is negative 2, x is 29 over 24, y is negative 1 over 12. For checking, you can't just do the checking part. You have to show the work. But for the checking, I'm going to enter 4, negative 2, 5, 2, 5, 2 as a 2 by 3 matrix. Do RREF. It'll give me those answers. If either one of those answers is wrong, then one of my determinants is wrong. So let me real quickly check this. Second matrix, edit, 2 by 3, 4, negative 2, 5, 2, 5, 2. Second quit. Second matrix math, RREF, second matrix A. Math, enter, enter. X is 29 over 24, y is negative 1 over 12. I feel perfectly fine about that answer. I didn't do the determinants by calculator because those are easy determinants. In problem 12, the determinants are going to be awful, and I'm going to do those by hand. So problem 12 also wants me to solve using Cramer's rule. To solve this using Cramer's rule, I'm going to have to find a D sub x, a D sub y, a D sub z, and then I'll get an answer for x, y, and z. And on the test, if I give you a Cramer's rule problem that has an x, y, and a z, you're going to be responsible for writing 7 different numbers down. The d is the determinant I get by pulling off the coefficients 1, 3, 4, 2, 5, negative 2, negative 1, negative 4, and 1. That's just pulling off the coefficients from the initial problem. The d sub x, I'm going to change the first column, the x column, in the D matrix to 6, 13, and 19. So I'm going to change the first column, the x column, and I'm going to leave the last 2 columns the same. 2, 5, negative 2, negative 1, negative 4, and 1. The d sub y, I'm going to take the first column of the D matrix, leave it the same. The z column of the D matrix, leave it the same. I'm going to change the y column of the D matrix to 6, 13, and 19. So let me just color code this maybe. So what I've done, the x matrix, I have the second 2 columns of the D matrix with the x column changed. The D matrix, I have the first and the third column of the D matrix with the y column changed. And the d sub z determinant, our matrix, I'm going to leave the x column of the D matrix, the y column of the D matrix, and I'm going to change the z column to the equal column, 6, 13, and 19. I don't want to do any of these determinants by hand, and you don't have to on the test. They're kind of monstrous to do by hand. So for each one of these, one at a time, I'm going to enter a 3 by 3 matrix, and I'll do DETA. So first one, I'm going to get D. To get D, I'm going to enter this matrix by going second matrix, edit, and typing 3 by 3 because it's a 3 by 3 matrix, and just going 1, 2, negative 1, 3, 5, negative 4, 4, negative 2, and 1. Double check. 1, 2, negative 1, 3, 5, negative 4, 4, negative 2, 1. Quit. And then second matrix over to math, enter on DET, and then second matrix, enter on names, enter again, and it's going to give me a number for D. D is negative 15. So in my answer, next to the D, I'm going to put the number negative 15. Now I'm going to find the D sub x by entering that one. If you're clever, you don't have to type the whole thing over because they're a lot the same, but I'm just going to type the whole thing over because sometimes when I try to be clever, I mess up. So 6, 2, negative 1, 13, 5, negative 4, 19, negative 2, 1 feel good. Second matrix math, enter. Second matrix names, enter. D sub x is negative 75. So next to the x, D sub x, I'm going to put negative 75. Moving on to the D sub y, I'm going to enter that 3 by 3 matrix. Second matrix, edit. It's a 3 by 3 matrix. 1, 6, negative 1, 3, 13, negative 4, 4, 19, 1. Double check. Feels good. Second quit. Second matrix math, enter. Second matrix names. D sub y is going to be negative 30. And lastly, I need to find D sub z. Second matrix, edit. It's a 3 by 3 matrix. 1, 2, 6, 3, 5, 13, 4, negative 2, 19. Double check. 1, 2, 6, 3, 5, 13, 4. It's perfect. Second quit. Second matrix math, determinant. Second matrix enter, parentheses. Negative 45 for D sub z. Now I'm basically done. X is going to equal to the D sub x number divided by the D number. The D sub x number is negative 75. The D sub x number is negative 75. The D number is negative 15. So I'm going to go negative 75 divided by negative 15, and I get 5. So my x is going to be 5. My y is my D sub y number divided by D, which is negative 30 divided by negative 15. I don't need a calculator to know that that's 2. And my z is my d sub z number divided by d. That's going to be negative 45 over negative 15. And I don't need a calculator to know that that's 3. Let me double check by doing RREFA on my calculator and making sure the far right column is 5, 2, and 3. So I'm going to enter a 3 by 4 matrix. This is just for checking. You don't have to check, but it's so easy to check. It's not the right method in terms of the method that you need to get points on the problem, but it's certainly easy to check, so I'm going to check because it takes under a minute. Sometimes I put this line here, sometimes I don't to represent the equal sign. It really doesn't matter whether you do or don't put that line in. It's just a matter of preference. So let me real quickly enter this as a 3 by 4 matrix. You get the same answer using Cramer's rule as you do RREFA. By hand, Cramer's rule is horrible. Matrices by hand are horrible too, but my calculator, this is fine. So there's the 5, 2, 3 that I wanted to get. All right, the next problems, you can do them all on your calculator on the test if you care to, or you can do them by hand. I'll do them both ways. So for 13, I need to do 2a minus 3f, easy enough to do. So for 13, asks me to do 2 times matrix A minus 3 times matrix F. That's going to be 2 times matrix A, which is 1, 0, 3, 2, 6, 1, minus 3 times matrix F, which is 1, negative 2, 5, 2, 6, 7. Multiply everything in the matrices, the left matrix, by 2. 2 times 1 is 2. 2 times 0 is 0. 2 times 3 is 6. 2 times 2 is 4. 2 times 6 is 12. 2 times 1 is 2. Multiply everything in the second matrix by 3. Leave the negative out there. 3 times 1 is 3. 3 times minus 2 is minus 6. 3 times 5 is 15. 3 times 2 is 6. 3 times 6 is 18. 3 times 7 is 21. Now subtract them. That's going to be 2 minus 3, 0 minus negative 6, 6 minus 15, 4 minus 6, 12 minus 18, 2 minus 21. For my answer to 13, 2 minus 3 is negative 1. This double negative goes positive and I get 6. 6 minus 15 is negative 9. 4 minus 6 is negative 2. 12 minus 18 is negative 6. 2 minus 21 is negative 19. Good enough. If I want to do these by hand, then I'm going to have to enter matrix A and matrix F. Each one of these has 3 rows and 2 columns. So if I want to do these, I'm going to enter matrix A and matrix F. So let me try to do that real quickly on my calculator to get the answer by my calculator. So I'm going to enter matrix A, which is going to be a 3 by 2 matrix. It's 1, 0, 3, 2, 6, and 1. Second, quit. And then second matrix, edit. Go down to enter matrix F. It's a 3 by 2 matrix. It's 1, negative 2, 5, 2, 6, and 7. Have both matrix A and F in. Now I'm going to enter 2A minus 3F by going 2. Second matrix names A minus 3. Second matrix names F. There's 2A minus 3F. Hopefully I see that. Negative 1, 6. Negative 9, 2. Negative 6, negative 19. Perfect. Did it fine by hand. 13 through 16, these grunge problems you can do on your calculator, they're just not that important. 14 wants me to do E minus C. So to do E minus C, E is 2, 3, 0, 4, 1, 4, 2, 6, negative 5. and then minus C, and C, you can't see, C is 1, 0, negative 1, 7, 2, 4, 2, 3, negative 5. To subtract these, I'm going to go 2 minus 1, 3 minus 0, 0 minus negative 1, 4 minus 7, 1 minus 2, 4 minus 4, 2 minus 2, 6 minus 3, negative 5 minus negative 5. So when I go to write my answer, 2 minus 1 is 1, 3 minus 0 is 3. This double negative makes this a 0 plus 1, so that's going to be a 1. 4 minus 7 is negative 3, 1 minus 2 is negative 1, 4 minus 4 is 0, 2 minus 2 is 0, 6 minus 3 is 3, and this is really negative 5 plus 5, so it's also a 0. Don't have to do that by hand. You could do it on your calculator. To do it on my calculator, I have to enter E and C as 3 by 3 matrices. Let me do those real quickly so I can get this done on my calculator. So second matrix, edit, go down to E, and my E is a 3 by 3 matrix. So 3 by 3, it's 2, 3, 0, 4, 1, 4, 2, 6, negative 5, 2, 3, 0, 4, 1, 4, 2, 6, negative 5. Make sure I did it right here too. 2, 3, 0, 4, 1, 4, 2, 6, negative 5. Perfect. Second quit. Now enter this matrix C. Second matrix, edit, go down to C, type in 3 by 3. It's 1, 0, negative 1, 7, 2, 4, 2, 3, negative 5. Looks like that's in properly. Now I just have to enter E minus C on my main screen. So second quit, then second matrix names E, and then minus second matrix names C. There's E minus C. Hopefully I see this. 1, 3, 1, negative 3, negative 1, 0, 0, 3, 0. My answer by hand is perfect. So addition, subtraction, and multiplication of matrices and scalar multiplication you're most welcome to do using your calculator. It's just not so important. For 15, to do A times E, I already entered, I think, A and E, so my calculator can do it. To do A times E, I'm going to take the matrix 1, 0, 3, 2, 6, 1, and multiply it by the matrix 2, 3, 0, 4, 1, 4, 2, 6, negative 5. My calculator's smart. It knows what you can and can't do when it comes to multiplication. To do matrix multiplication, I need to take this 1, 0 and write it next to each one of these columns as another column. So I'm going to take the 1, 0 and write it as a column, write it next to the 2, 4, 2. I'm going to take the 1, 0, write it next to the 3, 1, 6. I'm going to take the 1, 0, 0, write it next to the 0, 4, 5. You have the straggler down here that doesn't pair up. These can't be multiplied. My answer to problem 15 is these can't be multiplied. In my calculator, when I do it, it's going to say dimension mismatch. I know I just entered matrix E, and when I did problem 13, I entered matrix A. So I already have A and E on my calculator. So to get my calculator to give me the answer, I'd go second matrix names A, and then second matrix names E. There's A times E, and the error message is going to come up, dimension mismatch, it can't be multiplied. Next, I need to do A times B. I haven't entered B yet on my calculator, so let me just do that real quickly. Let me enter B on my calculator by going over to edit and down to B, and it's a 2 by 2 matrix. 4, I've already had in there, 4, enter, 5, enter, 1, enter, 2, enter. So I have A in there and I have B in there. So on my calculator, if I did second matrix A and second matrix B, there's AB, and it's going to equal to 4, 5, 14, 19, 25, and 32. Matrix multiplication you could use your calculator for. I'll show you quickly how to do it by hand, although it's not going to be so quick. So to do problem 16, to do A times B, I have to write the A matrix first and the B matrix second. The A matrix is 1, 0, 3, 2, 6, 1. And the B matrix is 4, 5, 1, 2. First, I'm going to get my top row by using the top row of A and writing it as a column, writing it next to the 4, 1 and the 5, 2. So I'm going to go 1, 0 written as a column next to 4, 1, and 1, 0 written as a column next to 5, 2. I'm going to multiply 1 times 4 and 0 times 1 and add. There's the 4 that starts my top row. And then I'm going to multiply 1 times 5 and 0 times 2 and add. There's the 5 that ends my top row. Next, I'm going to move on to the middle row of my answer by taking the 3, 2 and writing it next to each one of the columns of B. So the middle row, I'll go 3, 2 times 4, 1 and 3, 2 times 5, 2. 3 times 4 is 12. 2 times 1 is 2. 12 plus 2 is 14. 3 times 5 is 15. 2 times 2 is 4. 15 plus 4 is 19. Now I'll move on to the bottom row of my answer by taking this 6, 1 and turning it into the 4, 1 and the 5, 2. So I'm going to go 6, 1 times 4, 1 and 6, 1 times 5, 2. This is going to give me 24 and 1. Is that 25? This is going to give me 6 times 5 is 30. 1 times 2 is 2, which is 32. So you're more than welcome to do the matrix multiplication and addition or scalar multiplication by your calculator, but if you want to do it by hand, I did it by hand real quickly because I imagine most of you will use your calculator. All right. So doing math when you're tired is just a bad idea. This will be my third attempt at problem 17, and it's an easy problem, but when you're tired, nothing is that easy. So to solve a system of nonlinear equations, which we have here, the first equation is a line, the second equation is a parabola. So this would be a system of nonlinear equations. RREFA will not give the right answer because that needs both equations to be linear. So I can't use that. And although this problem could be solved by the elimination method, it's probably a bad idea when you have nonlinear equations to use elimination. It can be done, but more often than not, when students have a nonlinear system of equations and they try to use the elimination method, they usually make a mistake because they try to combine terms that have different exponents that can't be combined. The best way to solve this system of nonlinear equations is using the substitution method. And for the substitution method, you need to pick an equation and solve it for a letter. The obvious things to do would be to solve the top equation for x or the bottom equation for y. They both will work perfectly well, and I don't know that one is significantly better than the other. They both have their certain amount of grunge. So I'm going to solve the top equation for x and substitute into the bottom, probably as much as anything, because the last go at the video I solved the bottom equation for y and substituted in the top and made a mistake. So I'm going to try the other way. They both will work just fine. So the top equation is x plus 2y equal to 5. I'm going to minus 2y from both sides. and that's going to give me x equal minus 2y plus 5. And I'm going to substitute this into the bottom equation. So into that equation, I'm going to change the x into minus 2y plus 5. So I'm going to go minus 2y plus 5 quantity squared plus 1y equals to 10. Need to solve this for y, and then I can go back and substitute to get my answers for x. I need to clear this parentheses that I put in here, and I'm going to clear that parentheses by writing it without the exponent, and then I'm going to FOIL. First are going to be negative 2y times negative 2y, which is 4y squared. Outers are negative 2y times 5, which is negative 10y. Inners are 5 times negative 2y, which is negative 10y. Lasts are 5 times 5, which is plus 25. Then I still have the plus 1y and the equal to 10. Because of the exponent, this problem is going to have to be set equal to 0. And I'm going to do 2 steps for once right here. I'm going to minus 10 from both sides to get 0 on the right-hand side. I'm going to wind up with a plus 15 on the left-hand side because 25 minus 10 is 15. And I'm going to combine the like terms on the left-hand side that can be combined. That's minus 10y, and positive 1y. These two add up to a minus 20, and when I add 1, I get a minus 19. So this is going to give me 4y squared minus 19y plus 15 equals to 0. Now I'm in a position where I can solve by factoring, or I can solve by the quadratic formula. I'm better at factoring than the quadratic formula. The quadratic formula, in case you want to try it, is negative b plus or minus the square root of b squared minus 4ac all over 2a. Solving by factoring and solving by the quadratic formula give the same answers. So I'm going to try off to the side here. I'm going to factor 4y squared minus 19y plus 15 using bottoms up. And I'm going to multiply by 4 and rewrite. That's going to give me y squared minus 19y plus 60, because 4 times 15 is 60. And then I'm going to factor this. That factors into y minus 4 times y minus 15. My last have to multiply to 60 and add to 19. And then I'm going to divide by 4, reduce, and bottoms up. So since I multiplied by 4, I divide by 4. First fraction reduces to y minus 1. Second fraction bottoms up to 4y minus 15. So this is what I'm going to put in place of the 4y squared minus 19y plus 15. So I'm going to replace this with y minus 1 times 4y minus 15 equals 0. If you do the quadratic formula, you'll get the two answers I'm going to get here in a second without having to factor. But factoring for me is easier than the quadratic formula, and I'm tired, so I'm doing the factoring. So now I'm going to go y minus 1 equal to 0, add 1 to both sides and get y equal to 1, and then 4y minus 15 equal to 0, add 15 to both sides and get 4y equal to 15, and divide both sides by 4 and get y equal to 15 over 4. I need an x for each y, and this is the way I'm going to get my x's. I'm going to use that equation, and for each y I'm going to get an x. So I'm going to use x equals negative 2y plus 5. For the first y, I'm going to get x equals negative 2 times 1 plus 5, which is negative 2 plus 5, which is 3. That's going to give me the solution x equals 3, y equal to 1. For the next ugly one, I'm going to get x equal to negative 2 times 15 over 4 plus 5, and don't care to do that by hand. So x equals negative 2 times 15 divided by 4 plus 5. Math, enter, enter. I get x equal negative 5 halves. So the other answer I'm going to get is x equal negative 5 halves, y equals 15 over 4. So these are theoretically my answers to problem 17. Answers really should be checked, and they're not particularly hard to check, so I'm going to check them. First, I'm going to check 3(1). I'm going to check it into the top equation first. The top equation is x plus 2y equal to 5. I need to go 3 plus 2 times 1 and make sure that that equals to 5. And that I can do without a calculator. That works just fine. The second thing I need to do is check it into the bottom equation, x squared plus y equal to 10. That's going to be 3 squared plus 1 equal to 10. This would be 9 plus 1 equal to 10, which is 10 equal to 10. So 3(1) is definitely a solution because it makes both equations work. This horrible solution, I'm going to check on my calculator because there's no reason to do this by hand. So for the first equation, I'm going to go negative 5 halves plus 2 times 15 over 4, and that has to equal 5. So on my calculator now, clear, negative 5 divided by 2 plus 2 parentheses 15 divided by 4 equals, and I get 5 equal to 5, so it works in that equation. Into the second equation, I have to go negative 5 halves squared plus y, 15 over 4, and that has to equal 10. So again, on my calculator, no reason to do that by hand. So negative 5 divided by 2 in parentheses squared plus 15 divided by 4. I better see 10 when I hit equals, and I do. So I've checked my answer the only way I can check this answer. So this is in fact just a perfect answer for number 17. All right, one last problem to do. There's only been 18 problems, but it's been a lot of work. So 18 wants me to graph a system of equations and label the corner points. When we did these, right in the last section, we went from bottom to top. And when I do these, I'm going to, on a separate sheet of graph paper, first I'm going to graph x is greater than or equal to 0. To do this, you draw a vertical line through 0 on the x-axis, and you shade right. 0 on the x-axis happens to be the y-axis. So my very first graph, I find 0 on the x-axis, and I am going to draw my vertical line, and I'm just going to imply that I'm shading right, because if you do too much shading, your graphs get really ugly. So there's my line. I need to shade to the right, shade to the right. I would shade all of it, but it's just going to get too ugly. Moving on to the y is greater than or equal to 0. The y is greater than or equal to 0. I draw a horizontal line through 0 on the y-axis and shade up. Easy enough to do. I find 0 on the y-axis, draw my horizontal line, and I'm going to shade up. And just like the last few homework problems in this section, this confines my shading to the first quadrant, because the only where these two shadings overlap is in the first quadrant. When I go to do the rest of my shadings, I'm going to keep my shadings confined to the first quadrant. The next one I'm going to worry about is x plus y is less than or equal to 6. And I'm going to worry about those by getting x-intercepts first. So for the x plus y is less than or equal to 6, I'm going to graph a solid line of x plus y equal to 6. Remember, we started plugging in some 0, so I'm going to plug a 0 in for x and get 0 plus y equal to 6. That's going to give me y equal to 6. And then I'm going to plug in 0 for y. I'd get x plus 0 equal to 6. That's going to give me x equal to 6. So I'm going to plot the point 0, 6 and 6, 0, draw a solid line, and then I'll figure out where to shade. So real quickly, I'm marking 0, 6, I'm marking 6, 0, and I'm connecting these with a solid line. Arrows at the end of the line might be nice. It's hardly a deal if you don't. My checking point's going to be 5, 0 and 7, 0 for shading. So for shading purposes, I'm going to check 5, 0 and 7, 0, and I'm going to check them into x plus y is less than or equal to 6. First one, I'm going to go 5 plus 0, plugging 5 for x and 0 for y, is less than or equal to 6. That gives me 5 is smaller than 6, which is true. The next one, if I plug 7 for x and 0 for y, that gives me 7 is smaller than 6, which is false. So for this line, I want to shade towards the 5, 0. So this line is going to wind up shading. I'm going to keep my shading in the first quadrant, and I'm going to shade down towards the point 5, 0, which was the true point. Lastly, I need to shade 2x plus y is less than or equal to 10. And I'm going to start off drawing that. I'm going to graph 2x plus y equal 10 with a solid line. To do that, I'm going to get my intercepts. First, I'm going to plug 0 in for x and go 2 times 0 plus y equals to 10. That will give me y equal to 10. Then I'm going to plug in 0 for y and go 2x plus 0 equals to 10. That gives me 2x equal to 10, or x equal to 5. So now I'm going to plot the point 5, 0 and the point 0, 10. Connect them with a solid line. So 0, 10, 5, 0, solid line the best I can. Then I have to figure out which way to shade. For shading, I'm going to try 4, 0 and 6, 0 because they're on opposite sides of that x-intercept. So now for shading, I'm going to try 4, 0 and 6, 0. They're on the opposite side of 5, 0. And I'm testing them in 2x plus y is less than or equal to 10. So 2x plus y is less than or equal to 10. So let me plug 4 in for x, 0 in for y, and get 2 times 4 plus 0 is less than or equal to 10. This gives me 8 is smaller than 10, which is true. For the other one, when I plug in 6 for x and 0 for y, I get 2 times 6 plus 0 is less than or equal to 10. That gives me 12 is less than or equal to 10, which is false. So my shading needs to go in the direction of the 4, 0. So when I go to shade, the 6, 0 side I'm not shading, the 4, 0 side I am shading. So technically I'm supposed to shade staying in the first quadrant and shading down. Now I need to find out where all my shadings overlap and darken those up real nicely and label the corner points. So I'm almost done. Just pull out my highlighter here to emphasize how am I going to shade this. I'm going to shade in the first quadrant. I'm going to be underneath all my lines. So here I'm under the orange line. There I'm under the pink line. And I'm going to label my corner points here in a second. I did it nicely on graph paper, so this point where the lines intersect I might have very nicely. So this is the graph, but the instructions also say sketch a graph and label your corner points. Along the final shaded region, any x-intercept or intersection of lines is a corner point. So this point, that point right there, 0, 6, would be considered a corner point. It's a x-intercept around the final shaded region. The origin is an x-intercept, or at least it's a corner of the final shaded region. And that point 5, 0 is also considered a corner point. The point 0, 10, and 6, 0 aren't considered corner points because they're not allowed around the boundary of the final shaded region. That to me looks like the point 42. To make sure that's the point 42, I'm going to solve 116, 2110 using RREFA on my calculator just to make sure that my hunch that this is the point 42 is correct. So I'm going to go second matrix, edit, 2 by 3, and then 1, 1, 6, 2, 1, 10. Second quit, second matrix, math. RREF, second matrix, enter, parentheses. I better see 4 and 2, which I do. So my graph is perfect, and I found the corner points two ways. One by just looking at my graph and guessing it was right, and the other by actually doing the RREF. So this is the perfect answer. I graphed the bottom two to get me in the first quadrant, found the x-intercepts and how to shade on each one of these. Usually on the test, I make all down shadings just to make it easier to keep it in the first quadrant. It makes for a nice clean graph rather than having a graph that shades out. That's a little messier to do. So that's only 18 problems. It took a boatload of time. So really, really focus on this stuff. It's just really, really tedious. There's no word problems, which is kind of nice, but they're just, they just take a while. So just give yourself a good amount of time to digest this, and you should do really well on the test.